Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at the nomenclature of alkynes. So without further ado, let's get started. So before we start, what are alkynes? Okay, alkynes are unsaturated hydrocarbons, okay, and then they have the general molecular formula CnH2n minus 2. So this is their general molecular formula, and they have the functional group of what? Carbon triple bonded to a carbon. So this is their functional group, and then this is their general formula, where n is the number of carbons that we have, in the molecule. Okay, so with this said, alkynes are also what? sp hybridized. Okay, so that is the hybridization of the central carbon atom within any alkyne molecule is what? sp hybridized. Now let's move on to the main aim of this tutorial, that is how to name alkynes in case we are given one. So let's look at our first example. We have this as our example: triple bond to C, CH2, CH3. So the first thing you want to do if you have something like this is to first expand it so that you can actually see the bonds that you are having. So we have hydrogen bonded to carbon, and then triple bond to another carbon bonded to another carbon with 2 hydrogens, then another carbon with 3 hydrogens. So let's count the number of carbon atoms that we have in this molecule. So we have 1, 2, 3, 4. So because we have 4 carbons, it means our prefix is what? Bute. For 4 carbons, our prefix is bute. Now because we are dealing with alkynes, we add the ending YNE to it to get the parent name of the molecule. So the parent name of this molecule is what? Butane. Now because we have the functional group, which is the triple bond over here, we need to what? Indicate the position of the triple bond in this example. So we need to also give the triple bond the least locant, that is the least number, as much as possible. So someone naming this compound who names this carbon as carbon 1, carbon 2, carbon 3, carbon 4 will have the triple bond on what? Carbon 3. Someone counting in this direction will have the triple bond on carbon 1, sorry. So we like to choose the one that will give us the least locant as much as possible. So we will choose what? The one that will give us 1. So the name of this molecule is what? 1-butane. 1-butane or bute. 1-ine. Okay, so this is the name of this molecule. Let's look at the second example that we have. So we have CH3, 3 outside, then we have C triple bond to C, then C with Cl2, then CH2, CH3. So this is our molecule and we are supposed to name it. So first of all, let's draw the structure. So we have this carbon bonded to 3 methyl groups. So we have CH3, CH3, and we have another CH3 here. Then this is now the carbon bearing the triple bond C, bonded to another carbon, which is now having 2 chlorine molecules, bonded to another CH2, and then CH3. So here of course we need to count the number of carbons that we have in our parent chain. So we have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. So we have 7 what? Carbons in this example. So our parent name will be what? Heptane. So hept is for 7. So because it is an alkyne functional group that we are dealing with, the parent name is what? Heptane. Now let me also name the carbon from this side. So this is 1, 2, 3, 4, 5, 6, 7. Now you can see if we are counting from this direction, our triple bond is on what? Carbon 3. If we are counting from this direction, it's on what? Carbon 4. So we give it the least locant as much as possible. So this will be what? 3-heptane. Now any other group of atom that we find on the molecule or the parent structure is what we call the substituent. So we also need to name the substituent. So we have chlorine, chlorine, then we have CH3, CH3, and they do not form part of the parent structure. Okay, so we need to name them. So we have over here chlorine, and because we are using this 3-heptane, we are using this counting, not the top one, so forget the top one. So we have 2 metals on what carbon 2, so we have what 2 dimethyl. Because they are 2, we need to use the prefix di to indicate that they are 2, and both of them are on what carbon 2 of the parent chain. Then we have another 2 substituents, which are the chlorine groups, so and they are all on carbon 5, so we have what 5 what dichloro. Alright, so we just need to combine everything and we get the name of this molecule. But then we need to take note of something. That is what, if we see the molecule over here, we have chloro and then methyl. C comes before M, so we will go for the one with the what C, that is alphabetical order. So the name of this molecule is what 5 dichloro what 2 dimethyl 3-heptane. Heptane. Okay, so let's get rid of this and then we solve another example. Okay, so example number 3, we have CH3, CH2, then we have C with CH3 at the top, then we have CH2, C triple bond, then CH, then we have what CH2 here, we have CH3 here. Okay, so we need to get draw the expanded structure of this so that we can get the longest continuous chain, and then we from there name the compound. So we have CH3, then we have CH2, one of these, then another CH2 which is the second, then we have the C with the CH3 at the top over here. Okay, and then we have the CH2 at the bottom over here, then we have the carbon triple bond, carbon H, then we have what the CH2 over here, we have another CH2 over here. Alright, so let me get rid of this quick. Okay, so let's get our longest continuous chain. So we can see that when we count 1 2 3 4 5 6 7, we are going to get 7 if we count like this, but we will get what 5 and 6 when we count straight ahead. So we want the longest continuous chain, so we have 7, and then that is if we count in this way. Okay, but if we count in the other direction, we are going to get, let me use another color, green, for that. So we'll get 1 2 3 4 5 6 7. Okay, now looking at both directions, we can see that the number that favors the triple bond is the one that is having the 1 over here, so we give it the 1. So we are using the green for the naming, that is the green counting for the naming of this compound. So we have 7 carbon chain forming the parent chain, so our name is what 1-heptane. Okay, now that we have that as our name, we now look for any other compound that is on the parent chain and does not form part of the parent chain. So we have one here and then another one over here. Okay, so this CH3 is what we call what methyl, and if we are using the green counting, it's still on carbon 4, so we have what 4-methyl. Then we have 2 carbons with what 5 hydrogens, that is what we call ethyl, so we have what 4-ethyl. Now we just need to arrange this alphabetically and then we get our answer, I mean the substituents. So we have what E comes before M, so we have what 4-ethyl, 4-methyl, 1-heptine. Okay, so this is the name of our molecule in this example. Okay, let's have a look at more examples. So we have CH triple bond C bonded to another C, triple bond again, C and H. Alright, so for this particular compound we have what? 2 functional groups. Okay, so we are going to use, because we have 2 functional groups, it will be what? Diene. Okay, so the alkyne is what? Is 2 of them, so we have what? Diene. Now we have carbon 1, carbon 2, carbon 3 and carbon 4. It doesn't matter where we count from in this example because it will still be the same. 1, 2, 3, 4. So if it is this way, we have triple bond on carbon 1, so we have 1 on carbon 1, we have 1 on what? Carbon 3. In this direction too, we have 1 on carbon 1, 1 on carbon what? 3 over here. So it doesn't really matter in this example. Okay, so it means we have triple bonds on what? Carbon 1 and then carbon 3. So we have what? 1, 3 diene as our ending. Now we have 1, 2, 3, 4. Okay, which is what? 4 carbons, and 4 carbons we have what? Butane. Okay, but because this is a diene, we just add the ending over here to it and then we get our name. So then for this particular one, our answer is what? 1, 3 butane, okay, diene. So this is the name of this compound, the one with what? 2 what? Alkane functional group. Okay, the one with the 2 alkane functional group. So let's have a look at one final example. Alright, so we have CH3 C triple bond C, C triple bond C, and then Cl again. So our longest continuous chain in this example is going to be what? So when we count from this direction, we have 1, 2, 3, 4, 5. In this direction we have 1, 2, 3, 4 and 5. Okay, so let's look at something. When we are counting in this direction, okay, we have that triple bond on what? Carbon 2, and then we have another one on what? Carbon 4, so making a total of 6. In this direction we have it on what? Carbon 1, and then we have another one on what? Carbon 3, making a total of 4. So we will choose what? The counting, the top counting and not the bottom counting. This is a CH3. Okay, so with that we are using this counting, and then we have 1, 2, 3, 4, 5. So we have 5. So we have what? Pentane. We have pentane, and because we have two triple bond, it is what? Diene, pentane diene. Alright, now this diene, the triple bonds are on what? Carbon 1 and then what? Carbon 3. So we have what? 1, 3 pentane diene. Now we have a substituent over here which is on what? Carbon 1. So the name of this compound is what? 1 chloro 1, 3 pentane diene. Okay, so that is the name of this compound. So thank you so much for watching. I hope you've learned something new, and from now onwards you can name any alkyne that you have, no matter how complex the structure is. Just draw out the structure, see the bonds. If there are multiple bonds, you try to name them as diene or triene, depending on whether it is what? 2 triple bonds that you have or 3 triple bonds that you have. And then any part of the molecule that does not form part of the parent chain becomes a substituent, and then you name them alphabetically, and then you have the name of your compound. So thank you so much for watching, and I'll see you in the next video. Bye bye.